Okay, I'm making this video to share with you guys some of my findings and questions about this Joule thief circuit I've been playing with. I've got here a iron powdered toroid, and it has about 6 meters long of 0.25 millimeter wire. Gives you a total of about 0.31 millihenries of induction. I also have a 50k pot, and in here that you can hardly see there is a 2N3904 transistor. Now, I'll power the thing up. This meter here is showing lux as on the little sensor here. So I put my finger over it and it goes down. Hopefully you can see that. I'll just move the camera. That is the light in the room at the moment. I'll just hit relative so that we're measuring what we get off the LED. This one is measuring amps. I'll turn the light on so you can see. That's going to go out though. Now, one of the first things I want to mention is the harmonics we're getting on this scope here. It's currently set at 500 microseconds to a division, and I've got probably 20 divisions across my screen. As you will see, I'll turn this potentiometer, which is controlling the base charge on my transistor, up and down, and you get all sorts of crazy harmonics going through that. What's really of interest to me is that as you turn it down to a certain level, usually around the 5-6k mark, but it varies with every toroid and every battery. If you change the charge in your battery, it will change the amount of resistance the mode 2 kicks in. Now, as we can see over here, I'm just about hit 20 milliamps, which is of drain on my battery, which is about what the LED should be drawing on 3 volts, but we've got less than 1 there. And if I keep turning, somewhere around as we go up, whoop, there's mode 2. And you'll notice a big change on this scope here. I'm actually going to have to scale that down so that we can see it. Now, what got me into looking at the harmonics is looking at the way these spikes are all dancing up and down. And you can see the harmonics here. This one is at 20 microseconds a division. This one's at 500 microseconds a division. So if I scale the time out on this one, we're going to start seeing the same sort of stuff. I'll bring it back down to where we can see what's actually going on. Again, now at 10 microseconds. And I wanted to talk about the sweet spot, which is the point of maximum brightness. Now, it's not what you'd think. If I max that, that's my potentiometer maxed all the way out. We're getting 400 lux. And we're using over 200 milliamps. Now, if I turn this back, it gets brighter for a bit. Brighter, brighter. Oh, and I went past the sweet spot. The sweet spot is right where the current jumps up. And it does it, jumps up pretty sharply. And that's probably about as good as I'm going to get. 600 lux. And from what I was testing just before I started filming, I was getting nearly 700 lux with 80 milliamps of draw, which I reckon is pretty good. Oh, and one of my scopes just went flat, but we've seen what we need to off that one anyway. So, anyway, just some interesting findings, and if anyone's got any comments on the harmonics going on here, I'd be very interested to find out. And thanks for watching.